Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back to another live edition of the Bill and Corey Show.
Oh, yeah. This one's really live.
Yeah, it's really
extra live.
It's going to be interesting. So, I don't know the question. Corey's got the question. It's pretty much his show today. Mm-hmm. I'm going to sit here and
I'm reading
hold up props.
I'm reading a blank teleprompter right now.
I'll be the Vanna White. So,
all right.
Go ahead, Pat.
Let's put up the first slide, please, Roger. I don't know why I said Roger. So this is the problem. So we had a question from a customer, and they sent us this nice diagram. And my favorite part about the diagram is that they did such an engineering thing. If you look up in the top right corner, it says none of this is to scale.
That's a number one engineering thing you put on a drawing.
And the funny part is there's no way I would have assumed this drawing was to scale. But I love it because it's kind of funny. But so they're getting house end 2. It goes to a regulate or 30 psi. But
well, this is like a digital napkin. So
that's what. Yeah, yes.
So things don't format.
The digital napkin. They're just drawing this up on probably Excel. It looks like Excel, which is the digital napkin. But so they have, it goes to a regulator, it gets put down, the gas wants to be cleaned to go to a laser system. Now thinking about laser system, this got me thinking about how Star Wars is so unrealistic now. I do not see stormtroopers with carrier gas lecture bottles on the back so they can fire their weapons.
Yeah,
it doesn't make any sense. Where's the carrier gas? It doesn't make sense
they
anymore.
Don't have the...
So it takes me right out of the movie.
Fluorine mix on their back.
Ever since I learned how lasers need carrier gases, took me right out of the movie.
Tough.
But I digress. So their problem is their house N2 is dirty, and it messes up their laser, essentially. Long story short. So they want to clean their gas, and without using soap, I think.
That's the that old water filter thing. God, I won't even talk about that. But
so if we go to the next slide, that is a product we sell. It's our, what is that called, Bill? I don't even know off the top of my head.
It's part of our Laser Pro filter panel. Not a Laser Pro. I'm sorry.
It's a 3D. It's a 3D printer.
I'm sorry. It's a 3D printer. It's for metal 3D printing. They want to have clean gas too. People like having clean gas.
But I don't know why we need to just have this for 3D printing. Look at that. So the customer saw this.
Well, we built this for a
usually
metal
goes
3D printer.
Usually goes on the side of a. Is it a switchover?
Switchover.
Yeah. To help out, but just like Ozempic can be used for weight loss and diabetes, you can clean glass for 3D printers or lasers. So they saw this, they're like, this is really good. So what this thing is, it has 2 indicating purifiers, but the problem is they don't take out a lot because the indicating ones has the magic beads that purify the gas, and they have the magic beads that indicate whether or not the gas is clean. Yeah. And so it takes it down how much it can clean. And so this person thought, well, what if we put a bunch of them together? And then if you can click the next slide, they're like,
oh, that's what it's like.
Boom! What happened? Now does this make sense? I sent these slides.
A little bit sense. I looked at these slides and it was like,
out of context slides.
I'm sure he knows what he's talking about.
And so, but why do you need indicating ones on each one? And so, the idea, and it is in our literature actually, but we've never actually built one. If we go to the next slide, boom.
Boom.
So this is an idea, and we've never actually built one of these, but the idea
from our catalog.
From our catalog.
Our customers probably.
Our customers might have done it on their own and everything, but this is where someone's like, why don't you make a panel and we can put all these things on? We're like, taking it from our 3D, Laser Pro purifier. So as you can see, you can sort of daisy chain them in order, but obviously you don't need indicating ones in the first 3. You just want to indicate on the last one so you can get.
Look at the top one. It says moisture trap number 1, 2 is hydrocarbons, 3 is oxygen, then 4 is indicating oxygen trap.
Yes.
So I guess
in this one they cared about the oxygen. You can put an indicating triple one there. But the point being, the ones that don't indicate and just take out one impurity can take out more of that one impurity. So you put the three in a row in order to make it work, and then the fourth one, in this case, they want it to be indicating, and then it'll tell you, indicating, it'll change colors and let you know, hey, we need to start.
It'll talk to you?
Well, it will convey a message to you via color.
You could put like a little camera and do some AI stuff.
Well, no, and one thing I was thinking, I mean, this is something, but this has nothing to do with this. I was like, one thing that they could do is they could put a picture next to it of what it looks like when it's not colored. And it'll make it easy for people to, it's like, I was thinking of my 5C brain, but it has nothing to do with this question.
Got it.
And then, so I have a hypothetical for you, Bill.
Okay, you want to,
no, this needs to stay up.
Okay.
Keep this up. Theoretically, say you had a perfectly 100% O2 supply, and you put enough O2 purifiers in line, like enough, and you cleaned all the O2 out, what would be left? Would it create a vacuum? Like infinite O2?
It would create a fire.
It would create a fire, you think?
Well,
okay, let's do air. Well, let's do anything. I mean, because it would just purify all it out, and then nothing would be there.
That'd be called just use a vacuum pump, pull everything out. No, yeah, if you put oxygen going in an oxygen removing purifier, you'll probably
till it purifies a little bit.
I don't know if it'll burn up. It'll get really hot and it might burn.
You're focusing on the oxygen part too much and not the getting rid of all the gas part.
Yeah, no, just.
Yeah. All right. I digress. All right. So next slide, and I'm trying to think. Oh yeah, this is. Oh yeah. Oh wow, I messed up on these slides. Anyway, so this is what they. I don't know. So this
top one says
H2O in grams, but the second one shouldn't have been there yet. That one.
Milliliters of what?
Ignore that part. So this is our various purifiers, and not just the pure gas. It has the pure gas inline single, pure gas inline double. We don't need to look at all the graphs. It's just to highlight the differences in how much each one takes out. And you can see our 460s over there, which are the high capacity ones, have a way higher capacity than this one. We'll get there. We'll get there. And so hit it again. What's the next slide? I'm curious. There we go. That one is the one that was supposed to be there.
So you sent me a slide that's not.
Yeah, that's okay.
Oh, you did oxygen green.
I did oxygen as green, and then I had hydrocarbons as yellow. But I don't know if I sent you the right slide now. Yeah. But this one shows O2 being taken out, and not every purifier lists how much O2 can take, not every purifier can take out O2, so I don't list all the purifiers, just the one that can do it. Yeah. And then you can see as it goes single, double, triple, it goes down. And then, of course, the 6427, for some reason, it's low on moisture, but high on oxygen comparatively.
Okay.
So that might be something you want to do. And then click the next slide. And then this is the one,
the other one, hydrocarbon.
Hydrocarbon. So yeah, so this one takes out hydrocarbon. And then the final thing was, there's more than just what it takes out. You want to there's a lot of other things that can factor in, and it's almost like, and you can take out that slide and then come back to us. So come back to
there we go. Okay, we can show props. We got props.
We can show props. And so Bill was wanting to show props during that. We can go back. So this is the high capacity one.
It's the high capacity.
And as you can see, high capacity is a little bit synonymous with size.
Yeah. So this
says more.
But this is different specifications.
It is different specifications.
And it's not going to get the same level as these guys.
And originally, the customer's like, "Can we put this on?" And it's like, I don't know how to mount this. This one, so now you have to think about mounting. Which
this is a little cap to the bottom.
Yeah, it's a little thick.
It's not set up.
I don't want to go back to our mounting, videos, but that's something you have to consider. So, size and mounting. This guy is our low capacity, high pressure. So if so one of the last things you want to do, which was on the last slide, is pressure. What it can take is a very important thing. Like, you don't want to blow out your purifier.
Yeah. So this is kind of neat. Well,
typically not meant for right off the cylinder.
It's got, if you want to zoom in on that, it's got a couple mounting screws there. I think we might have sold a bracket or two here, or someone might just say, "Hey, I'll get a bracket and use this, mount it with the screws there."
There you go.
Yeah, this is higher pressure. So if you're running high pressure, that's something you have to watch out for. Mm-hmm. These are rated for
160. Well, 150 and 160.
Yeah, so about 150. Yeah. Let's just say. And this is going to be a lot more than that. So you can't run.
That one goes 2,000 pSIG.
Yeah, it's going to.
And 500 in oxygen, like Bill was talking about before.
Yeah. Yeah. So you can't just say, "Oh, I'll use this."
Yeah.
And they're not all the same pressure.
And all the same pressure. As well as this one is, one of them higher flow, I think. I can't remember.
This is higher
That's
flow.
higher flow as well. So
Yeah.
flow rates are very important as well. You can't just be chucking through like
Couple cubic feet a
supersonic
minute or something like
supersonic air, and the beads, they don't have time.
What was the customer looking for? What kind of
4
flow?
liters per minute.
So it's not
4 liters per minute is not tough. These ones do 25 liters per minute.
Yeah.
And then I don't remember the
These
other.
do higher.
Higher, this one, yeah.
Yeah.
But but if you're passing the gas over the beads too fast and the magic beads can't perform their spell before it leaves it, it's not going to take the gas
You want
out.
to show them the indicating?
Oh, yeah.
Did we show this before?
We have showed this
It
before,
has
but
brackets on it already.
but yeah. So this is the mounting part.
Little clip-on brackets.
Little clip-on brackets. Another one that we don't have here is our 6427. That one
that's
can be done with
a
brackets.
little bit bigger.
But yeah, so this one can be put up, and this one mounted straight in, straight out. And then obviously another crucial thing is pressure drops. These ones do not have a high pressure drop, so it's about a half a psi. But obviously, if you start daisy chaining them together, it'll compound the problem. This one, I can't remember what this one is. This one's about 3, I believe, depending on how fast.
Well, it depends. That's
and it
a
depends
higher
on how.
flow
Yeah,
rate.
it depends on how fast you're flowing through it. And
If you're
things of that
flowing
nature.
4 liters a minute,
It's not gonna. The pressure drops like.
Got
that.
arrows on these things.
And that's another thing. So I was like, ooh, you can daisy chain them. And when I saw the picture, I was like, why can't you just go in through the bottom, out through the top, and like that?
Put a little U thing.
Put a little U thing on there. Well, the flow, it has to be put in a vertical flow going up. So there's an arrow on there because of the way the beads can settle and things of that nature.
Yeah. It's like gravity.
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 It's like gravity.
So you put these
And these
in
do
a
not
space station.
defy gravity.
They're going to hit you in the
And
foot.
I'm to fly, defying gravity. No? You did it, Bill. I wasn't even
Sorry,
going to
you
go with
didn't.
gravity. That wasn't even in my head.
No, yeah, so use these in the space station. You might have some problems.
Well, no, that is, we laugh, but that is, but they have
Well,
there are sometimes things go up into space that we have sold, and we have to think about gravity.
We saw a rotometer, which was kind of funny. We laughed about that. Because the ball's not floating anymore. But what they did was they preset the valve, and they sent it up. And
or
then,
you can do a magnetic ball. Like, if you get the
just-
magnet to be perfect.
So another thing with these purifiers is magic beads in here, and you definitely don't want to have these types horizontal because the beads could settle a little bit, and then you could have the gas sneak through the top.
Passing through.
So it's not you can pack it only so hard,
Tight, yeah.
and then you could have some settling. So that's why you want to have. You got arrows on there. Follow that direction. It says in, out. Follow that direction.
Up and yeah.
Like this says in, out on here.
Oh yeah, and of course this always has the helpful illustrations of what colors they change to.
And you probably want to have that so you can read it.
Yes.
So yeah, these don't have cool illustrations.
So yeah, gas purity, and this also was interesting because because there was a lot of leak points in the so there's different ways you can combat this. You can either tighten up your leak points and
their system.
Their system,
we were talking about it. They have it's coming off liquid nitrogen, very very good source. Only problem is they have piping that
comes off of it.
Yeah, well, piping. I don't know when it was made.
Yeah.
And they got a lot of dead legs. And the problem with dead legs is you can get impurities. Nice word for junk in your dead legs, and they'll slowly bleed out over time. So just think of it. You got big long dead leg, and you got
it's like when
impurities in there, and it's hard to get them out.
Oh, it's like when we do our oh my goodness, I'm blanking on it. Purging, yeah.
Cross-purging.
Cross-purging of dead leg. Eventually it's going to pull out those impurities and do it.
Yeah.
And so all I'm trying to say is sometimes if, this isn't possible, you can look at your system and figure out sometimes, you can make your system cleaner just by designing it better as well.
These will probably be cheaper
Redesign the whole. I'm just saying in general, just trying to be helpful, Yeah. So, wow.
Any more slides?
No more slides.
Okay.
We have
we have this.
We have our moisture indicator, which is a
This is our
crude but
moisture.
useful.
Yeah, this is not as fancy schmancy as these beads for level.
It's essentially what you find. It's a silica gel. It's what you find.
It's a silica gel.
It's what you find in packaging.
Kind of. Yeah, it's pretty much. Yeah, that's why it's vacuum packaged here, so you won't get any moisture in your air in there. And these are, what's kind of nice about this silica gel is that you can regenerate it. You can toss it in the oven, and we tell you what it is. It's
like
funny, we tell you
150.
how to regenerate it, and people still buy replacement plugs all the time. Like, okay, that's fine. You can just.
Well, they might not have an oven on hand.
Yeah, they might not. So, yeah.
So another way. Yeah, there's all kinds of ways, and then I can't think of anything else.
So I think we kind of covered all our topics for this week.
You can daisy chain them together. And
Yep.
you can work.
And then you can mix and match, but
Mix
you have
and
to look
match
at.
them.
Yeah.
Takes a lot
And
out,
you don't
and it
wanna-
gets into the cleaner
and
part.
You don't want to have
the
like,
stages.
oh, we have industrial grade gas, and we want to make it UHP grade.
Oh
You
yeah. That's
burning through these things.
There
and
are
everything.
limits. There are limits to what these can clean. Yeah.
It's like,
it's
oh,
not-
I got an idea to save money on buying UHP gas. I'll get cheap gas and purify it.
Yeah, you can't send air through a line and then hope to purify all the O2 out to get into
No,
it.
it's just. Okay.
In
so
theory, though.
that's enough for this week. We didn't talk about what our question is for next week, so we forgot to do that. this week.
It's a mystery.
So it's going to be a mystery. I have an idea about like pressure rating stuff, but we'll have to talk about it because we've had a few issues about putting high pressure things in low pressure systems.
It will involve some variations on flow and pressure.
It's just,
I guarantee it.
so mystery question next week. So tune in again next week for another live edition of the Bill and Corey Show.
Set your VCRs.